Rahim. Assalamu alaikum. Today I welcome you again in the lecture series of digital filter design, and today we are going to implement IIR low pass filter. So what is the difference between the IIR and FIR? The difference is the feedback. IIR filters are feedback system, and they okay, that is basically the impulse response of the IIR low pass filter. Transfer function IIR low pass filter has a 1 over alpha over 2 and 1 plus z inverse over 1 minus alpha z inverse. Idea is very simple and same like FIR filter. To implement IIR low pass filter, we just need to put 1 0 at z is equal to minus 1. Let's go to the whiteboard, and if I draw the pole 0 plot, idea is simple. We need to implement a low pass filter. We just need to put 1 0 at z is equal to minus 1, and the flexibility it gives you, we can put one pole, a pole that control the cutoff frequency. That gives you flexibility. You can easily implement different ideal IIR low pass filter using this first order filter by simple changing the location of this pole. You can put this pole value, this and this, but make sure this alpha value, the pole position, should be less than 1. Keep in mind the stability concept. The pole should be strictly lie inside the unit circle, so you can easily control the value of pole and improve your cutoff frequency by simple with the limits of changing the position of this pole using this formula. We need to just put the value of alpha. Alpha is equal to 1 over 1 minus sine omega c. Omega c is a cutoff frequency. If we are going to implement a cutoff frequency of implement the IIR filter with the cutoff frequency of 0.5 pi, we don't need to design a IIR filter. We can simply implement this filter with the FIR filter. So if the cutoff frequency is more than 0.5, then you can go for the IIR filter. You don't need to just cascade the other filter. You can simply find the frequency response, cutoff frequency by using this alpha formula and calculate the filter coefficient. So let's go to the MATLAB and calculate the filter coefficient and implement this filter in the MATLAB. That is our MATLAB screen, CLC. Oh, sorry. Today I think my laptop is working very slow. Okay. Now now if I want to design a low pass filter with cutoff frequency omega is equal to 0.45 pi. In the case of FIR filter, we want to cascade to first order filter. In this case, we don't need to cascade the first order filter to first order filter. We just need to write the formula and calculate the value of alpha using the Now what is alpha? Alpha is equal to let's suppose A is equal to 1 minus sine omega c, 1 minus sine omega c is equal to 0.45 into pi divided by cos of 0.45 into pi. We calculate the value of alpha. Now simple put into the formula means pKs are now my response underscore response pKs is 1 because low pass filter, and AKs are 1 minus 0.0787. And if I simply press the enter key, and you can see the response of a low pass filter is implemented. That is basically a not bounded real transfer function. If you want to make it bounded real transfer function, what you need to do, we need to just multiply one whole transfer function 1 minus alpha over 2 that I didn't write into the MATLAB, so that's why it is happening. You can see you can easily implement any low pass filter. You can see the response, how can we change the value of alpha and control our frequency response. 0.9, 0.7, 0.8. we don't need any cascading. 5, 4, 3 and 2, 1. So that is very simple design. We are just controlling or moving this alpha value pole position to control the cutoff frequency of the low pass filter. That is very useful and easy to design as compared to the FIR filter. So hope you people like my lecture, today's lecture. You can share my lecture. If you have any query, you can ask in the comment section. See you next time. Allah Hafiz.